All right, so today's topic of discussion is I just want to explain how RMS values work. And this is for my Physics 106 video, but there's a ton of different applications to RMS values within engineering, math, and of course physics. And what we're exploring today is really kind of just the basics of RMS value, which RMS means root mean square. And this has to do a lot with AC current versus DC. So first of all, I just want to kind of explain those differences. First, you have DC current. And DC current is an electric current that is unidirectional, so it's always going to be flowing in the same direction. And alternating current is kind of just the opposite of that, contrasting it, where the current flows. It's still an electric current, but it periodically reverses direction, and that's kind of the two main differences. So this would be AC current. And the root mean square value really comes into play when we're dealing with AC current, and it's kind of how you equate this AC current to your original DC current. So I just kind of want to walk through the steps of calculating that value and how it pertains to this DC current value. So the first step of finding your RMS for your AC current is you're gonna pick a different couple points on this first part of your wave. You could do both parts, but we're just gonna stick to this first part. So let's pick this 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll do 0 as well. So let's say this is 6.2, and we've got 11.8. And we've got 16.2, 19 is this value, and then our peak is at 20, we'll say. And then we're going to add those as well to their corresponding values on the other side. So 19 again, 16, 11.8, 6.2, and 0. And then, so once we get all of our values, we're going to square all of those. And when we get that square, we're going to get that our voltage in RMS is going to equal so you get the square, and then you do the average of these. So there's 10 of those values. So we're going to do all of these squared, which comes out to 2,000 divided by 10. So we're going to get 200, and then we're going to take the square root of that, which is going to bring us to 14.14 volts. And that's our root mean square value. And what's so important about calculating this value is that is how it pertains to this DC current. If we have a DC current, this is what this value here would be equal to a DC current of the same magnitude. So there is a couple of different constants that you can use to relate this AC current to DC current when you have a sinusoidal wave. But that's kind of the gist of it, and you can use this application to apply it to different resistors and lights in series or parallel, and then you can calculate what the voltage is getting to those resistance.